Dear friends, imagine a material so dense it makes lead look like air, so strong it could withstand the crushing pressure of a collapsing star. This isn't science fiction, it's nuclear pasta, a bizarre form of matter found deep within the hearts of neutron stars. Neutron stars are the incredibly dense remnants of massive stars that have collapsed at the end of their lives. Inside these stellar corpses, gravity exerts unimaginable pressure, forcing protons and electrons to combine into neutrons. These neutrons then arrange themselves into fascinating shapes, resembling spaghetti, lasagna, and other types of pasta, hence the name nuclear pasta. But nuclear pasta is more than just a quirky name. It's a mystery waiting to be solved. Does this exotic material truly exist? What are its properties? And could we ever harness its potential? So stay with us to explore it. Nuclear pasta, or neutron pasta, is a theoretical type of degenerate matter that exists within the crust of neutron stars. It is a bizarre and fascinating state of matter that arises from these stellar remnants' extreme pressure and density. Massive stars, many times the size of our sun, eventually run out of fuel and collapse under their gravity. This collapse triggers an explosion known as a supernova, which leaves behind a core so dense that it crushes protons and electrons together, transforming them into neutrons. This incredibly dense object, roughly the size of a city but with a mass exceeding the sun, is a neutron star. Within the neutron star's interior, the pressure is so immense that it forces the neutrons to pack together uniquely and intricately. Depending on the depth and pressure, these neutrons can arrange themselves into different shapes, resembling spaghetti, lasagna, sheets, spheres, and other forms, hence the name nuclear pasta. As the name suggests, nuclear pasta is primarily composed of neutrons. However, it also contains a small percentage of protons and electrons. The exact proportion of these particles depends on the depth within the neutron star. The nuclear pasta consists of 99% of neutrons, 1% of protons, and 0.1% of electron. The presence of these protons and electrons plays a crucial role in the formation and properties of nuclear pasta. The repulsion between protons helps to prevent the neutrons from collapsing completely, while the electrons contribute to the overall electrical properties of the material. By understanding the formation, appearance, and composition of nuclear pasta, we can gain valuable insights into the extreme conditions that exist within neutron stars. This knowledge can help us unravel the mysteries of these enigmatic cosmic objects and explore the limits of our understanding of matter in the universe. The incredible density and unique arrangement of neutrons in nuclear pasta give it immense strength and rigidity. Theoretical calculations suggest that it could be the strongest material in the universe, surpassing even the most advanced materials created on Earth. This exceptional strength arises from the nuclear force, the powerful force that binds protons and neutrons together in atomic nuclei. In nuclear pasta, the close packing of neutrons allows the nuclear force to act over much larger distances, significantly enhancing the material's overall strength. Although directly testing the strength of nuclear pasta is currently impossible, its theoretical properties suggest it could withstand immense pressure and resist deformation even under the most extreme conditions. Nuclear pasta doesn't exist throughout the entire neutron star. Instead, it is believed to form a thin layer, roughly 100 meters thick, just below the star's surface. This region experiences a specific range of pressure and density that favors the formation of the various pasta shapes. The existence of this layer has important implications for our understanding of neutron stars. It suggests that the surface and crust of these objects might not be as simple as previously thought. The presence of a complex material like nuclear pasta adds a new dimension to our understanding of these enigmatic stellar remnants. By delving deeper into the properties of nuclear pasta, scientists hope to unlock the secrets of stellar evolution and gain a deeper understanding of the fundamental forces that govern matter in the universe. The potential applications of this knowledge are vast, ranging from the development of new materials on Earth to furthering our understanding of the cosmos. Although theoretical models strongly predict the existence of nuclear pasta, direct confirmation remains elusive. The immense pressure and density required to create this exotic material make it impossible to replicate on Earth. Currently, scientists are exploring various methods to indirectly probe the presence of nuclear pasta in neutron stars. One approach involves analyzing data from radio telescopes, which can detect faint electromagnetic signals emitted from neutron stars. These signals can potentially reveal information about the properties of the star's surface and crust, offering clues about the presence of nuclear pasta. Another promising avenue is gravitational wave astronomy. Gravitational waves, ripples in the fabric of space-time, can be generated by events involving neutron stars, such as mergers or collisions. By analyzing these waves, scientists can potentially learn about the internal structure of neutron stars and gain insights into the existence of exotic materials like nuclear pasta. While we have a basic understanding of some properties like strength and density, much remains unknown about the specific characteristics of nuclear pasta. Scientists are actively researching to refine theoretical models. By improving theoretical models that describe the formation and behavior of nuclear pasta under different conditions, scientists can develop a more comprehensive understanding of this material. Conduct laboratory experiments. While replicating the extreme conditions within a neutron star in a lab is impossible, scientists can use high-pressure experiments and advanced simulation techniques to study the behavior of neutrons under similar conditions and gain valuable insights into the properties of nuclear pasta. Develop new observational techniques. Advancements in astronomical telescopes and detectors could allow us to gather more detailed data about neutron stars, potentially providing crucial clues about the existence and properties of nuclear pasta. The immense strength and density of nuclear pasta make it a potential candidate for revolutionary new materials on Earth. However, the vast distance to neutron stars and the challenges of manipulating matter under extreme conditions make harvesting this exotic material a distant dream for now. Future advancements in space travel and technology might one day allow us to explore and extract materials from these celestial objects. However, significant ethical considerations and technological hurdles need to be addressed before even considering such an endeavor. The future of nuclear pasta research is brimming with possibilities. By unraveling its mysteries, we could unlock new avenues for scientific discovery and technological advancement. The journey to understand this fascinating material holds the potential to revolutionize our understanding of matter, the universe, and perhaps even our place within it. Thanks for joining us in the entire video.